Hello YouTube. So in the last video, which I incidentally just finished making, I did another update on my robot. If you haven't seen it, I went over it. That's explained in that video. But in this video, we're actually going to unbox the components which I just bought for it. You may be wondering why I didn't shoot it all in just one video. Well, I think the subject of it is different enough where I could make two videos. Also, I haven't made many videos, and that one was already getting to 10 minutes, so I thought I could have more. So these are the 5-volt regulators, which you might have seen. I bought 3 of them. So this one, and this one. I'll open one right now. So I bought these off of Amazon. They're for this is DC to DC. DC 12 volt, 24 volt, 36 volt to DC 5 volts at 10 amps, 50 watts. It says solar system on it. I guess it's for solar panels if you have that. But basically what it does is it converts 12 volts DC to 5 volts DC, and I could provide that at 10 amps, so you could get 50 watts of power going through this. And that's important because I need this to power the upper motors of this robot. So how I did it is I got 3 of these, which should give me more power than necessary actually. You may be wondering why I got 3 of these. So that gives me 30 amps of power. Yes, so how I have them is this one's going to power control circuitry like this Arduino, all of the switching of the relays, all the potentiometers, this accelerometer, which I'll get to shortly. So basically all the electronics will be powered by this. All that together for the entire robot should be much less than 10 amps, but just to make the circuitry simple, I got one just for the controls. These other 2 are actually for the motors. You could see the hip motors of this robot. Yes, this motor and this motor. They are 18 volt drill motors, and they spin really fast. And even with this gear reduction, for the robot to walk, it really only needs to move it a few degrees. So even with 75 to 1 gear reduction, the motors spin too fast, and that could cause problems. Yes, they could spin too fast, and we need to control them within a few degrees. So when I test them, I usually do it with 5 volts, and that's 5 volts coming from this power supply down here, which is a computer power supply. So when I have the batteries for the robot, it'll be 12 volt batteries, so I need these. At full power, these motors should only use 4 amps, but again, I have 2 of them, which could be 1 for each motor, which should be more than enough. Even one of these should be able to power both of these motors at full power. And keep in mind, each of these only run for a couple seconds. So I probably am going to have an extra one of these, which could be useful for a torso, which might have 2 more of these motors or some other ones. That just as they are there. So back to what we have here. As I said, I got 3 of these. Converts 12 volts to 5 volts. So hopefully these work out good. Next, I guess I should get to this, which I was talking about. This is an accelerometer. This is an obvious purpose on the robot. It's an Adafruit. Let's see if we could focus it here. It's an Adafruit ADXL335. You could read the rest of it. Accelerometer. You can see it right here. Yeah, so this is an accelerometer. It doesn't want to focus in, but it has XYZ out. and it has these little header pins which could connect onto here. And this will give you your X, Y, and Z position for the robot, and whether it is accelerating in this way, or this way. And that's necessary because it'll basically help the robot keep balance when it's walking. This will be in the center of the robot, and if it's falling, it can sense that it's falling because it'll be accelerating, and then it could correct in either direction with the motors. So this is going to be operated by the Arduino, which I have. This thing right here. So this is going to send signals to all the motors, make it so that it walks, but if it accelerates, it will back up until it stops. And hopefully by doing that, it could catch itself when it falls. That's a rough idea of how this is going to be programmed. So I think this would actually be safe right in here, and I'll try messing with this soon to make it actually do something. Next, getting onto these larger boxes right here. This box right here is a DC circuit breaker, which, DC 100 amp circuit breaker. So I just kind of guessed on getting 100 amps. This robot, even if it has a torso and it's moving at full power with all the motors, it should never consume more than 50 amps, roughly. So if it's consuming 100 amps, that means there's a short circuit and the circuit breaker will break. And this is going to be the main power line for the entire robot. So power will come in from the battery here and then come out here. Usually you do it with the positive line, and you could reset it. Also, even if it's working fine, this could be used as a switch. So you could turn it off with that and turn it back on with that. And that's a main power switch to control the robot. And of course we have a main power switch. We have 5-volt distribution. You may be wondering, how am I going to actually distribute power to all the circuits? Well, here is the answer to this. This is an RV truck boat thing. It's a fuse box thing. Try to get out of here. So here's the instructions with it. Specifications. It's a fuse box. It has LEDs to indicate which fuse is operating, and then has negative lines. So anyways, you have this. Oops, let's get out of here. Basically, it's a covered fuse box, so it's not going to short circuit anything accidentally. Yeah, so yeah, so I guess you push those in and it slides off like that. So power will come from the battery in through this and then out into here. This will be positive and this will be negative. And it comes with a bunch of fuses. So red is 10 amps. Blue is 15 amps. Orange is 20 amps. And well, yellow is 20 amps and orange is 5 amps. So that gives you a variety of different circuits that you could have. Stuff like the motors will have higher amperages, but no single circuit I think should consume more than 20 amps, so we're good with that. And this is all the positive leads will connect in through here. So let's say I want to hook up one of these, and I could plug it into here, and then the ground of course could plug into here, So that's your negative, which is the ground. And then you could get 5 volts out of here. And this is 5 volts at 10 amps. So at 12 volts, it should consume much less than that. So yeah, like I mentioned, none of these should consume 20 amps at 12 volts. That is 240 amps, which is more than anything here uses. Yeah, like I mentioned, this is for like a boat or a truck or something. Because it comes with stickers, which are auxiliary fog lights, freshwater navigation lights. So yeah, bait pump. Yeah, this is like for a boat, so it could power an entire boat electrical system. But we're just using it for a robot, which, though it is quite big, it should consume much less than that. It also comes with screws to screw this into wood or something. So, yeah, that's the stuff that I bought. Let's look at the robot again, and just where stuff will go. So, like I mentioned, the accelerometer will go like around here. The battery might go here as well. This thing and this thing is gonna go on the back of the robot, so it'll be kind of like that. I don't want to actually move the robot; it's quite heavy, and that gives easy access to the power switch where I could just, and then it's off if it's doing something which I don't want it to do. I could turn it off easily, which is good for the design. So what I'm going to do is hook up all this stuff, and I'm gonna try to get all this wired up to power. And once I have that, I could wire up the accelerometer, the Arduino, and I could actually get this thing moving. Hopefully, we'll see that soon, and I'll see you in the next video.